Hello and welcome to another video. This time we're going to be looking at getting started with B Simple, a new programming language for your Agon. So what is B Simple? It's inspired by the language B, but really it's a bit like a simple version of C. So anyone that's used C or Arduino, it should be pretty familiar. It's compiled to Easy-AT assembler for speed, and you write your code in a simple text file with the BS extension. You can also import extra libraries which are written in assembler. You can edit your file, compile it and run it directly on your Agon. However, if you'd like to, you can do the same on your PC by building the compiler for your platform. And what's the language like? Well, the data is quite simple. There are only 24-bit numbers and strings. So you don't need to worry about ints, floats or anything else. You're just restricted to 24-bit numbers, which keeps things simple. Numbers and strings can also be stored in arrays. However, you can use pointers to directly address the memory where that data is stored. There are built-in maths and logical functions, as well as string manipulation commands. And program flow can be controlled with loops, function calls, and even go-tos to labels. In order to get things started, you need to make sure that you have the B Simple compiler in your bin directory, as well as the Easy-AT ASM assembler. And if you're going to use Nano to edit your code files, then you'll need Nano in the MOS directory. So here's the process. You write your code with Nano or whatever text editor you prefer. You compile that with the B Simple compiler, and it produces a file which you can then assemble using the Easy-AT assembler. Once that's done, you get a binary which you can run natively on the Agon. So in MOS version number 2, you type in Nano and then the file name to edit your code. And when you finish with Nano, you simply type BSC and the file name. This will produce an assembly file with a .s extension, which you can then assemble using the Easy-AT assembler. Once that's complete, simply type the file name of your binary and it should run. Let's take a look at some of that in action. If we want to open the Hello World example that's been provided, we type Nano and then the name of the file. And here we are in Nano, and we can edit the file. This is the Hello World example, but not only does it print Hello World to the screen, it also demonstrates how you can format text and numbers in different ways. So once we leave Nano, we're in MOS and we type in BSC and the file name we want to compile. It's fairly quick, it's processed a file and it's created a hello world.s file that we can then assemble. Once we've created our file, we can then run it. And here's the program running. It printed Hello World, and it demonstrates some of the formatting of decimal, octal and hexadecimal, as well as a string sample. For those that have moved up to version 3 of MOS, there's a new command we can use, which will help us automate this process. It's called the obey command. Here I've created a small obey script, simply 3 lines long. The script can execute all the commands which are in the file, but it can also substitute some of the arguments that are sent in within that file. In this case, %0 is substituted with the file name. So we can run the script by typing obey, the name of our script, and our file name. But here we're going to omit the .bs extension so that it can work it all out for us. So this 3-line script will compile the program, assemble it, and run it automatically for us. We can take a look at that in action. And there we can see everything was automated, the compiling, the assembling, and actually running the code. So if you'd like to try out Be Simple, download it from the GitHub repository. There are several other examples to try out, each highlighting a different feature of the language, from file management to mathematics. When you're ready, try writing some of your own programs. Maybe create a number guessing game. Or include some graphics.